Okay, so this is a really interesting curve, quite a cool curve actually, and a very common one at our level that we're dealing with polar coordinates. Simple enough equation, r equals a sine 3 theta. Okay, I'm going to talk you through how to sketch it and a reminder about how to sketch any curve in polar form. Okay, well, table of values is something to go for. Sometimes we don't need all of these values. I've just given you an example of a template. So between 0 and pi, and of course you can have another table from pi to 2 pi. But as you're going to find out, we don't actually need to have all of those values filled in. You'll soon see why. And here's the polar grid template, okay? So the initial line and the pole, and I always find it extremely useful to put in pi over 2, 3 pi over 2, and pi, okay? Effectively an x and y axis in Cartesian form, but shouldn't call them that with polar coordinates, okay? Shouldn't call them, but it is handy to have these in. Sometimes I'll label that as theta as negative pi over 2, but for this example I've just put it as 3 pi over 2, okay? Now, let's have a look at this, a sine 3 theta. Well, the 3 theta there should make us stop and think for a little bit, okay? What I've done is I've sketched out a graph of what y equals sine 3x looks like. I've put x and y because it's Cartesian, okay? And you notice between 0 and 2 pi, we can fit 3 of the curves in. Okay, we can fit 3 of the curves in. So what that means is all we need to know is what is happening between here and here. And then it's repeated all that time. So we only need to know what's going on between 0 and 2 pi over 3. Or in other words, we only need to look at that bit there. Okay, so straight away in our table, we only need to go up to there. We don't need these bits, okay, because it's going to be repeated after that. So first of all, what I'm going to do is I'm just going to rub those bits off. I don't actually need them. So can you see what I mean by sometimes you don't need to have all the values listed between 0 and 2 pi, okay? We only need to go up to 2 pi and then it'll be repeated after that, okay? Now, let's have another look, okay? The graph is interesting because, well, to me it's always interesting because it's trigonometric, okay? But you can see all the y values are positive between 0 and pi over 3, and all the y values are negative between pi over 3 and 2 pi over 3. So what does that mean in the context of this equation here? Well, remember, r as a value, we always take to be positive, don't we? Okay, we always take r to be positive. So that means is these values here, where sine 3x are negative, they're what we call undefined values for our polar curve, okay? It's going to be undefined between pi over 3 and 2 pi over 3. So what that means is, if I just find a pen there, okay, we don't actually need to use those values there. They're not going to appear on our graph, okay? They're not going to appear. So really what I'm saying is then, we only need to worry about 0 to pi over 3, okay? And then we'll see what happens after that. So let's just have a look then. So between 0 and pi over 3, if we substitute that in, sine 0 is 0, so that's going to be 0. And then we've got 3 times pi over 6, so that's going to be pi over 2. So that gives us 1, so 1 times a, so that's a. That's going to be our maximum value. Notice our maximum value of r, that is, okay. And then pi over 3, times that by 3, you get sine pi, that's going to be 0 again. So what the curve is doing is it's starting off at 0, and then it's stretching out to a, and then it's coming all the way back in again. Okay, let's just see what that looks like, okay? So we're interested in the lines theta is 0, which is the pole, of course, sorry, the initial line, of course. Theta is pi over 6, and theta is pi over 3, okay? So that's pi over, so it split into 3. In other words, okay, so here would be pi over 6. Best to use a ruler when you're doing this on your page, okay, on your notebook. And this here would be pi over 3. Usually when you put those on, it's a good idea to label theta as pi over 3, theta equals pi over 6. Okay. And what's happening is, when you've got theta is 0, r is 0, so that's a point that's to be plotted, you see. And then when theta is pi over 6, you've got r equals a, that's the maximum value, so I'm going to put it there, okay. And then when theta is pi over 3, so along this line, it's 0 again. So what's happening is the curve is going to go out to here and then back again. Okay, drawing it such that the initial line is tangent both there, so not both there, and that the line pi over 3 is tangent there as well. And that's kind of what it looks like. It should be symmetrical both sides. Okay, I've not done such a bad job there, to be honest. Okay, that's that. Right, let's talk about what happens next. Okay, between pi over 3 and 2 pi over 3, there's no graph to be drawn. Okay, there's no graph to be drawn. So I'm just going to write those out. Okay. But then from 2 pi over 3 up to pi, it's going to repeat itself here. Okay, I'm sure that makes sense to you. Okay, so we've got this graph here. So between 0 and that's pi over 3. Okay, we've got the graph, but then from pi over 3 to 2 pi over 3 we ignore, but then we include this bit from 2 pi over 3 up to pi. Okay, where it's positive again. So we'll include that bit. Okay, and from 2 pi over 3 you can check these, you'll get exactly the same values. Okay, obviously 3 times that is 2 pi and sine 2 pi is 0, so you get, let's just put it in, 0 there. Any multiple of pi, of course, you'll get 0, and the one in between, that's going to be what, 4 pi over 6, 2 pi. Sorry for the stupidness on my part. That would be 5 pi over 6, wouldn't it? Okay, just check that. So pi over 6, 2 pi over 6. Yeah. Yeah. And that will give us a value of A. Okay, so when you times it by 2, so if you times it by 3, you get 5 pi over 2. 5 pi over 2 is the same as pi over 2, and yeah, so R times that A, yes, you're going to get A. Okay, so that means is I'm going to want to draw the next phase of the graph. Okay, so it's going to have what? So this could be the mirror image of this effectively, using this as the line of symmetry. So we're going to have this bit here, should be a straight line really. Theta equals 5 pi over 6, and another line here. It's kind of awkward doing this. How does that look like? It's a straight line. Reasonable, I suppose. So that's theta equals 2 pi over 3, and then just draw it in. I'm just trying to get the radius bit correct. So there, okay. So you can see at 2 pi over 3 it starts at 0. Okay, so just draw it so it's tangent, and then it will curve inwards to that point there, and then it will come back in to 0 when I equals pi, and I just draw it out this way so that it's definitely going to be tangent to it. There. That's that. Okay, and then we've just got to figure out where the rest of the graph is going to go. Let's just bring you back to this again. So that's from 0 to pi over 3, and then 2 pi over 3 to pi, and then ignore that bit because it will give you negative values, and again we don't want negative values of r. Effectively it's not there. Can you see sort of between here and here, you see there's nothing there, there's nothing to be drawn in. Okay, and then the next bit we want is from here to here. Okay, so it's going to be from 4 pi over 3 all the way to, what's that there, going to be 4 pi over 3, that's going to be 3 pi over 2, isn't it? So it's 8 pi over 6, 10 pi, 5 pi over 6. Sorry for the, is that right? No, not 5 pi over 6. So yeah, 8 pi over 6, 10 pi over 6, 5 pi over 3. Sorry, I've just got to make sure I get it absolutely right. See, okay. So between 4 pi over 3 and 5 pi over 3. And maybe I could have just Maybe I've just spotted it's going up in thirds. 0, 1/3 pi, 2/3 pi, 3/3, 4/3, 5/3, 6/3. Never mind. I won't redo the video again just because of that. All that means is between 4 pi over 3 and 5 pi over 3, it's doing exactly the same thing. Okay, so in other words, from 4 pi over 3 up to 5 pi over 3, it's doing exactly the same thing. And exactly halfway between that is 3 pi over 2. That's why I was going, incidentally, that's why I was looking at 8. You might have heard me mutter 8 pi over 6, 10 pi over 6. In the middle of that is 9 pi over 6, which is 3 pi over 2. Okay, that's why I kind of went into 6th mode. So what we're going to do is we're going to have the last phase of the graph down by here. So just get on my knees again. This bit is going to be so I'm just trying to make sure I'm doing this kind of accurately. That bit there, that would be theta is, what did I say, 4 pi over 3. And then this bit here, that's going to be theta is equal to 5 pi over 3, like that. And you can see it's just going to go out and back again. Just try and get some sort of scale correct. Looks kind of okay. Then just draw it such that this is a tangent. Goes out, and then this is a tangent. Goes out, and how's that looking? Not too bad. So not too bad. Okay, so in time you can probably just do that. But in an exam, of course, you've just got a few minutes. But when it's the first time you see this, you've got to kind of know what's going on. You've got to kind of know what's going on. Okay, now. Just be careful, if you do go and research a different syllabus, sometimes they put these bits in, okay? It really does depend on the syllabus. As far as I'm concerned, that's not really appropriate because I prefer to think of the value of r being a radius, a positive value, and not being a negative value, so it's more appropriate to have the 3 there. And also, look at this as well, when you've got a sine of 3 theta, you've got 3 of these petal-shaped graphs. Okay, might look like an airplane propeller, the old style airplane propellers, but it's a petal-shaped graph. You've got 3 of these petals actually in. Okay, can you see what would happen if I changed that to 5 theta? You'd end up with 5 of these petals. Okay, if I changed it to 2 theta, you'd end up with 2 of these petals. Okay, so knowing what number appears there is generally quite useful. Okay, I'm hoping you found that helpful. I hope that you understood it. Okay, remember, watch the video again if you just want to see again some of the explanations. Okay.